Hi guys, in this video we'll be speaking about NS2, that is Network Simulator 2. In this video we'll show the detailed procedure for the installation of NS2 and also demonstrate the working of NS2 using example codes. Before we see the installation of NS2, let us see what basically NS2 is. NS2 stands for Network Simulator 2. NS is a discrete event simulator targeted at networking research. NS provides substantial support for simulation of TCP, routing, and multicast protocols over wired and wireless networks. It was developed by UC Berkeley. Now it is maintained by USC, and NS2 is a popular simulator in scientific environment. Next, we'll see the goals of NS2. So the main goal of NS2 is to support networking research and education in protocol design, traffic studies, etc. in protocol comparison. New architecture designs are also supported. NS2 is freely distributed and it is an open source tool. One of the main goals of NS2 is to increase the confidence in result. Next, we'll see the languages that are used in NS2. NS2 uses two languages, that is C++ and OTCL. First, we'll talk about OTCL. OTCL stands for Object-Oriented TCL. It's an extension to TCL for Object-Oriented Programming. It is used to build network structure and topology, which is the surface of your simulation. It's easy to configure network parameters with the help of OTCL, but it is not enough for research schemes and protocol architecture adaptation, because of which the other language C++ is used. Next is C++. C++ is the most important and kernel part of the NS2. C++ is used to implement the kernel of the architecture of protocol designs. C++ is mainly used to change or comment out the existing protocols in NS2. Now let us see why two languages are used in NS2. The two requirements of NS2 simulator is runtime speed, which is the detailed simulation of protocol, and easy to use, which means that it's easy to vary parameters or configuration in NS2. C++ is fast to run but slower to code and change, and OTCL is easy to code but runs slowly. So for these two requirements of simulator, we use two languages, C++ and OTCL. Next, we'll see the components of NS2. First component is NS2, the simulator itself. We'll use the version NS2.35. Next is NAM, which is the network animator, which is an animation tool for simulation. Next is a pre-processing, which involves the traffic and topology generators. And next is post-processing, which involves a simple trace analysis, often in AWK, Perl, or TCL languages. Next, we'll see the NS2 directory structure. NS is object-oriented simulator written in C++ with an OTCL interpreter as front-end. Simulator supports a class hierarchy in C++ called as compiled hierarchy, and a similar class hierarchy with an OTCL interpreter called as interpreted hierarchy. These two hierarchies are closely related. There is one-to-one correspondence between a class in interpreted hierarchy and the class in compiled hierarchy. So the simulator is actually the base directory. Simulator here in our case is NS2.35, and the next level we exactly have TCL 8.0, OTCL, TCL, NS2. This NS2 directory exactly contains all of the simulation modules. Then under NS2 TCL, this TCL directory will exactly contain all of this interpreted modules of interpreted hierarchy. Under TCL, we exactly have the example folder. So there are exactly inbuilt examples present in NS2, which can exactly be viewed in this example folder.
Now we'll start with installation of NS2. We are installing NS2 in Ubuntu 14.04. First, download the NS2 from the URL. Click on the download button. This might take few minutes depending on your internet speed. Next step is setting up the prerequisites. The downloaded ns2 zip folder will be there in the downloads directory. Copy that and move it to home, username, documents directory. Now we have pasted in the documents directory. Next, open a terminal and we should update Ubuntu with its latest components. Type the following commands in the terminal. This makes sure that Ubuntu is fully updated. It's just asking for password. Now it's updating. It might take few minutes. Next, type the following command. Next, run the following command in the terminal. This also updates Ubuntu. Also, make sure that there are no pending updates in your Ubuntu Software Center. It is updating. Okay, next we'll have to install some essential packages that is required by NS. So run the following three commands in the terminal. We are copying the first command and installing. Next, copy the second command. After running this command, the first step of setting up the prerequisites will be done. Okay, the first step is done. Now we'll go to the second step. Next step is extracting and installing ns2. Right click on the downloaded ns package and click extract here. After extracting the ns folder, open the ls.h file. You can find this in ns all-in-one 2.35. Next, select link state. In this, you will find the ls.h file. Go to line 137. This change must be done or else we'll get an error while installing ns2. Now see the line 137. Replace arrays with this arrays. Click on save file. Now we'll install ns. Open up a terminal and move to the directory where you have extracted the package. This can be done by using the change directory command. Now we'll install ns. Type /install. This might take some time, so please have patience. After installing, we'll get the following state. This means that we have successfully installed. Now we should set up some environment variables, which is a third step. This can be done by editing the .bashrc file. Open a new terminal. It is very important that we do it in a new terminal or else we'll get an error. Open the terminal and type the following command: sudo gedit .bashrc. It is asking for password. Now at the end of this file, we're supposed to add few lines. Copy this at the end of the file. Also, be sure to change /part2 to the path where you've extracted the ns, that is /home/username/documents. This must be done in 9 places. First, second, third, fourth, fifth, sixth, seventh, eighth, and ninth. After this, save the file. After saving the file, we should reload the bash file. In the terminal, type the following command. This is the final step. After this, we'll have validation. Setting up environment variables is done. Next, we'll validate and see if everything is okay. Open a terminal and move to the directory. Move to this directory. Now type /validate. This might take about an hour, so please wait. Now the validation step is completed. Type ns in the terminal. We get a percentage sign indicating that ns2 is successfully installed and validated. Next, we'll demonstrate how to use ns2 with examples.
In NS2, we use both TCL as well as C++ programming languages. TCL is used to build network topology and C++ is used to implement new protocols in NS2. Now we'll run a sample TCL code and see. First, you have to open a terminal and type gedit your program name, which here in this case is example1.tcl. We already have the code here. So after typing the code, just save the file, close it. Now to run this, type the command ns example1.tcl. Now the network animator opens. NAM stands for network animator. Network animator is an animation tool for viewing network simulation. Now let us understand the code. The first line creates a simulator object, which is ns. Next, this line actually opens a file out.nam in write mode and the file handle is nf. In the next sentence, we are telling the simulator object to write all the trace details into this file, which will be utilized by the network animator. Next, we'll see how to define the network topology. These 4 lines create the 4 nodes, which are 0, 1, 2, and 3. These lines actually connect the nodes. Duplex link is used. We have used a bandwidth of 1 MB, delay of 10 milliseconds. Droptail, SFQ are active queue management algorithms. These lines tell the orientation of the nodes. So N1 and N2 are oriented right and down. N1 and N2 are oriented right and up. N2 and N3 are oriented right. This line monitors the queue. We are monitoring the queue between the nodes 2 and 3. Next, after creating the nodes, we have to create the agents to send the data. So we are creating an UDP agent and attaching it to node N0. So this lines create an UDP agent and attach it to node N0. Similarly, we're doing for node N1 also with the help of these lines. Next, after creating the agents, we'll attach the CBR traffic source for this agents. So these lines will attach the CBR traffic to node N0, and these lines will attach the CBR traffic to node N1. So after creating the sources, next we have to create a traffic sink. So null agent, you have to create a null agent as a traffic sink, and here we are attaching it to node N3. So the sources and the sink are connected with the help of these two lines. Next, you have to tell the simulator object when to actually start and stop the CBR traffic, which is done with the help of these lines. Next, at the end, finish procedure is called. So the finish procedure actually closes the trace file and starts the network animator. Now, if we play the network animator, we can see how the data is being sent. So node 0 is actually sending the traffic to node 3 via node 2. So the color blue is used to blue and red are actually used to differentiate the traffic between these two nodes. See here, color 1 and 2 are used for that. And here the packets are dropped. If suppose the packets actually exceed the queue capacity, they'll be dropped. So since we are monitoring the queue between node 2 and 3, the packets will be dropped in that queue. Ns2 provides the feature of labeling the nodes for easy identification. Here we have only 4 nodes, so identification won't be a problem. But in cases where there are many nodes, identification will be a problem. So labeling nodes is important and helps in better understanding. So the 4 lines here will help in labeling the nodes. So N0 is labeled as node 0, N1 as node 1, N2 as node 2, and N3 as node 3. So these lines are added in our previous code. Save the file, and now we'll run the network animator. So when you play the network animator, the nodes will be labeled as node 0, node 1, 2, and 3 respectively.
Now let's learn about trace file. Trace file contains information about the data that is being transferred in the network. We'll see how to create a trace file. To our previous code, we are adding the following lines. This line creates a trace file test.tr, which is opened in write mode. The next line tells the simulator object that we created the trace file to write the trace data to the file. In the finish procedure, we're supposed to make the following changes. Add nt, the trace file handler, along with nf. Also, we should close the trace file with the help of close nt. Now we'll see the trace file format. The format is shown here. First, there are 12 fields. First one is the type identifier. Type identifier can be plus, which is a packet enqueue event. Minus indicates that a packet dequeue event. R indicates that the packet is received. D indicates a packet drop event. C indicates packet collision at the MAC level. The second field is the time, which indicates at what time the packet was created. Third field is the source. Fourth field is the destination node field. Fifth is the packet name, which is the name of the packet type. Sixth field is the packet size, which is the size of the packet in bytes. Seventh field is a flag string. Eighth one is the flow ID. Ninth and 10th are source and destination address. 11th is the sequence number. 12th is the packet ID, which will be unique. Now we'll see how to open trace file of our code. Open the terminal and type gedit test.tr. This opens the trace file we created. We'll see an example. In the highlighted row, R indicates that the packet was received. 0.514 is the time. 0 is node 0, which is the source. 2 is destination, node 2. CBR is constant bitrate traffic. 500 is the packet size. Similarly, the other fields. Now after generating the traces in NS, we can interpret the trace data to get useful information like the number of packets which are received at a node, number of packets dropped, the throughput of the network. Now on a trace data, we'll run an AWK script which will count the number of packets dropped. Before that, let's understand what is AWK. AWK is programming language designed to process the text files. AWK refers to each line in a file as a record. Each record consists of fields. An AWK script can be specified at a command prompt or in a file. We will write it in a file. Open the terminal, type gedit filename.awk. In our case, we already have the AWK script, so we'll just save it. Now to run this AWK script on the trace file, which is test.tr in our case, we use the following command: awk -f drop.awk test.tr, which is the trace file. Now the output will be the number of packets dropped, which is 435 in our case. Now let's understand the general form of AWK. This is the general form. It begins with the begin keyword followed by any initialization which has to be done before the processing. Next, it has a set of patterns followed by action set for each of those patterns. It ends with the end keyword followed by the final action set, which is usually the printf statements. Now in our code, we will understand what are we doing for the packet drop. Now we'll see our AWK code. We will initialize the packet drop to 0 because we're counting the number of packets which are dropped. Then the pattern is event is equal to $1, which indicates the first column in the trace file. It can be plus, minus, R, D. If it is D, it means that the packet is dropped. So if the packet is dropped, we are incrementing the variable packet drop, and it ends with the end statement where we are printing the total number of packets dropped. Now similarly, if you want to find the number of packets received, then the event will be R and the count will be similar.
In the next example, we'll see how to add a new protocol that could be implemented in NS. The code implements some sort of simple ping protocol. One node will be able to send a packet to another node, which will return it immediately, so that the round trip time can be calculated. New protocol implementation requires .h and .cc files. Both the files should be placed in NS all-in-one 2.35, then NS 2.35 apps folder. So both your ping.h as well as ping.cc should be placed in this folder. Now we'll see the ping.h. In ping.h, first you're supposed to define the structure for your packet header. So character RET. So this RET will actually be 0, will be set to 0 if the packet is on its way from sender to the node which is being pinged. And it will be set to 1 on its way back. Send time. Send time will actually contain the timestamp that will be used to calculate the round trip time. Ping agent. Ping agent is actually a subclass of this agent class, and there are exactly two functions, command and receive. Off ping. Off ping will be used to access the packet's ping header. Next, we'll see the C++ code. In the C++ code, the linkage between the C++ and the TCL code has to be defined. So first we'll include the header file, which is #include ping.h. Next, we have defined the ping header class, which is actually subclass of your packet header class. And similarly, we have ping class, which is actually a subclass of TCL class. We have defined a constructor for this ping header class and also constructor for this ping class. So this class ping htr is actually an instance or object of your ping header class, and class ping will be the object of this ping class. So this is actually the constructor for this ping agent, where we're exactly binding the variables which will be used both in your C++ as well as TCL code. So next we'll see the two functions which are used, that is the command and the receive function. This is the command function. In this command function will be called whenever in the TCL command the class ping agent is exactly being executed. In our case, it will be this. Whenever this command is exactly executed, the command function in the C++ will be called. So this command function will actually create a new packet and will exactly set the values for the ping header contents, that is the RET and the send time, and it exactly sends the packet. So next we'll see the receive function. This receive function will exactly define the actions that have to be taken whenever the packet is exactly being received. So if your RET is actually equal to 0, then you have to send a echo packet. You will save the old packet's send time, which is done by this line, and again you'll exactly send the echo packet back. Next, if your RET is exactly equal to 1, then call your tcl.eval function with the ping result, and finally at the end you're supposed to discard the packet. We should make some changes in some of the NS source files if we want to add a new agent and it exactly uses a new packet format. We need a new packet type for a ping agent. So first step is to edit the file packet.h. So you have to go to this NS all-in-one 2.35, NS 2.5, and in this you have to search for the file packet.h. So open this file. Now we'll see the changes to be made in this file. The first change that has to be made is you have to define a constant packet size for this. So at this line, add the new statement, static const packet t in caps lock pt myping is equal to 73. Change this 73 to 74. First, initially in NS 2.35, NS 2.35, in apps folder, you're supposed to place your myping.h and myping.cc, which are the cc and the .h files of your protocol. Now in packet.h, after doing this change, the next change is you have to search the class pinfo. Here's the class pinfo. So in this, you're supposed to define the type is equal to pt myping. So type is equal to caps lock pt myping and you're supposed next changes After this change, next you're supposed to do the changes in data packet. So here also should do the same thing. Type is equal to caps lock pt myping. The last change which has to be done in this packet.h file is you have to come to line number 421. Here in the previous line, you have to type name pt myping is equal to, type it as myping. So after doing these 4 changes in packet.h, save the file. Next, the next change which has to be done is in this ns2.35, you have to search the ns default file. ns default.tcl. Here in agent, you have to search agent here agent. Here you're supposed to add a new line, agent slash myping. Set the packet size as 64 and you're supposed to save this file. Next change which has to be done is in this ns 2.35 again, you're supposed to again search makefile. In this makefile, you're supposed to make the following changes. Search for app slash ping.o. So here, give a space and type app slash myping.o. And next you're supposed to save it. Now after doing all the changes, you have to type the commands make clean and make in directory. For that, you have to move to the directory ns2.35. So copy that path, go to a terminal, type change disk, paste the path. Now type make clean and now type make to redo all the and to recompile the ns. So this will be the final state after make command has been executed. Now we'll run the TCL code. So supposed to type gedit xyz.tcl. So this is the TCL code. Now just save it. Close this TCL code. Now type ns xyz.tcl. This will be the output. So node 2 will receive the ping answer from node 0 will receive the ping answer from 2 with the round trip time 42.0 millisecond. So this will be the output. Okay, now if we will run the network animator, the ping packets will be sent. Now let us understand the ping.tcl code upon which the myping protocol will actually run. So first we are creating 3 nodes N0, N1, N2 with these 3 lines. Then we are connecting the nodes N0, N1, N1, N2 with duplex links. Then we're supposed to define the receive function which will actually receive the value from the receive function of the C++ file. and it'll exactly print the value with the statement put s. So this will print the value of the round trip time. Next, we're supposed to create the ping agents and connect them together. So we are creating a ping agent p0 and attaching it to node n0. You're supposed to specify new agent myping. So myping will be your protocol. Then you're supposed to create ping agent p1 and we are attaching it to node n2. Then we are connecting the ping agents p0 and p1. Next, you're supposed to schedule the events, like when the ping agent should exactly send the packet. So we're sending at point 2 p0 will send, and point 4 p1 will send. So finally the last line is ns run. As we have already told, ns contains a default example folder which contains certain default examples. Now we'll run one of those examples. So you have to go to that example folder which is present in ns2.35, then the tcl folder, then the example folder. So there are certain default examples. You can open each of them and see what they exactly do. Now we'll run an example, flooding.tcl. So this flooding.tcl, each node will actually forward a message if it sees for the first time. If it sees for the message for the second time, then it doesn't forward it. So the code is actually simple to understand. The nodes are exactly created. You create a bunch of nodes, you create the links between them, and you attach the agent message passing flooding for each of these nodes. Now we'll run this flooding.tcl. Open terminal, type gedit flooding.tcl and copy the code here, which I've already done. Save it and close it. Next, run it. So ns flooding.tcl. So the network animator opens. If you want, you can re-layout it. Now if I play the network animator, the messages will be displayed here. So if the node sees a message for the first time, it prints the message. If it's a redundant message, it'll print as redundant copy. So at the end of simulation, we can see the messages. Each node, what are they doing?
Thank you for watching our video.
For more documentation, refer NS manual and Margaret's tutorial.